Okay, well, today we're going to talk about system of equations. System of equations. Okay, and what that means is basically where two equations or more that create a system that exists kind of simultaneously. So a lot of times you'll see, um, for example, here's an equation, y is equal to 8 thirds x, and then plus 3. And then you'll have another equation, y is equal to negative 2 thirds x minus 7. And then they'll either tell you it's a system of equations, or sometimes you'll see the curly brackets. And what the curly brackets kind of show us is that this, in fact, is a system. And what that means is that we can put them on the same plane. Okay, so we can actually graph these two systems. And when we graph these two systems, what will happen is we'll actually see a point in which the two lines will intersect. So let's look at the first one. Let me go ahead and draw a little graph here. And let's go ahead and do some lines here. 2, 3. All right. So we can see that these are already in slope-intercept form. And the slope-intercept form, if you recall, is this form right here, where you have y is equal to the m is your slope times your x. So for this first one, my slope is 8 thirds. And for my second one, my slope is negative 2 thirds. And then plus b, and b is your y-intercept. So I can go ahead and for my first equation, and I'm going to put those points in um, here. So we have positive 3 for where it crosses the x-axis. I'm sorry, the y-axis. Now we can look at the slope. So slope is defined as rise over run. We can go up 8 over 3, 1, 2, 3, 4, 5. That's going to kind of put me way up here. So I'm going to go down 8 to the left 3. Because that's the same thing. If we go up 8 over 3, if we go down 8 to the left 3, that's going to create a straight line. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Okay, then we can kind of guesstimate over here. 1, 2, 3, 4, 5, 6, 7, 8, let's say, and then 3 we know to be right there. So we'll think about that. So that should be roughly as best as we can do without graph paper or a straight line. All right, that's the first equation. Now let's go ahead and graph the second one. All right, let me choose a different color here. Okay. So this y-intercept is negative 7. So that's going to be way down here. Okay, and then I'm going to have a negative 2 over 3. So negative 1, 2 over 1, 2, 3, kind of off my graph a little bit. So we can go the other way, 2, up 2, and to the left 3. Up 2 to the left 3, 1, 2, 3. So it looks like these two are going to cross at about that point. Now, since I am doing this not on graph paper, let me see if I can look up the answer here just to make sure we're doing this one correct. All right, that's actually right. Good. All right, so what we notice here at this point, that is at -3, -5, is that we have an intersection. In that point of intersection is where we're solving these two equations, okay? This point right here, -3, -5, solves these two equations. So what do we mean by that it solves? It means where they intersect. So if we think about this, every point here, so let's take this point right here on this red line, okay? This point right here is 0, +3, okay? Notice that the point 0, +3 does not exist on the blue line. Now let's pick a point on the blue line that does not exist on the red line. If we come down here, 0, -7. Okay, that's this point here. And of course, that point there, this point here. Only this point, -3, -5, exists on both lines. And we could pick any point here on the red line that's not on the blue line and figure out what that ordered pair is. But what you would have is you would have an x value, okay, and a y value that will work if we plug it into this equation that represents this line. So what that means is if I took the 0 here for x and I plug that in, I get 3 for y, which makes sense. I plug in 0 for x, that goes to 0, I add 3, that's 3, my y is 3. But if I take this point down here and I try to plug it into this first equation, if I plug in 0 for x, my y is 3, my y is not -7. Now, vice versa, if I plug in this point into my second equation, the 0 in for x would make y -7 and not 3. So this point does not satisfy this equation. But this point does. This point does because every point on the blue line, every single point on the blue line is satisfied by this equation. And every point here on the red line is satisfied by this equation. But this specific point right here, -3, -5, works for both equations. And so they share that point. That is their point of intersection. So if I plugged in -3 for x, -3 times 8 over 3, the 3's would cancel, and I'd be left with -8. Okay, -3 over 3 would give me -1. -1 times 8 would give me -8. I could also do -3 times +8 to get -24, divide by 3, okay, to get -8. However you work that, you're going to be left with -8. Then when I add 3, that's going to give me -5. Now down here, when I put a -3 here, -3 over -3, let's say, that would just be left with a +2. -7 is -5. Or I could do -3 over a +3. That would leave me with a -1. -1 times -2. +2. +2 minus 7, -5. So however I do that, for both equations, the point -3, -5 satisfies both equations. All right, and so this is what's called solving the system of equations using graphing. Okay, so when we solve system of equations using graphing, that is what we can do. So let's do another one. We're going to do, let's say, 2x. This time I won't put it in slope-intercept form. I'm going to put it in standard form. All right. So if this is a system of equations, I can graph those two. So what I'm going to do is I'm just going to kind of make some points. Okay. Um, you, we can do several things. I'm going to call this equation 1, and I'm going to do it in blue. So I'm going to have an x and a y. I can algebraically solve this for y and turn it into a slope-intercept form. That is also a valid way to solve these if you want. I'm also showing you that you can just make ordered pairs. Either way is fine. So let's do, these are kind of big numbers. Looks like we have multiples of 5, so I'm going to try to make it easy on myself. -10, -5, we'll say 0, 5, and 10. Okay. All right, so if I plug in -10 for x, I'm going to get, and I'll go ahead and write it here, 2 times -10 plus 5y is equal to 30. Okay. All right, so this is going to give me -20. I'm going to kind of work that over here, I think. Probably should have done that over here. Let me go ahead and do that. -10 plus 5y is equal to 30. -20 plus 5y is equal to 30. Add 20 to both sides. 5y is equal to 50. So my y is just 10. Because I'd have to 5 times 10 is what gives me 50. So I'm going to go ahead and draw a line through this and just make my 10. That'll be easier. So -10, 10. Now let's do -5. I do 2 times -5 plus 5y is equal to 30. 2 times -5 is -10 plus 5y is 30. Add 10 to both sides. 5 times y is 40. So 5 times 8 gives me 40. So this -5 makes my y become 8. Okay. Next is 0. That'll be a little bit easier. 2 times 0 is 0. So that just leaves me with 5y is equal to 30. Y has to be 6. All right. Next, we're going to have 5 in for y. So 2 times 5 plus 5y is equal to 30. So this is 10 plus 5y is equal to 30. Then I'm going to subtract 10 from both sides. And I'm left with 5y is equal to 20. And that gives me 4. Y has to be 4. 5 times 4 is 20. Next, I finally have 10. So 5 times, I'm sorry, 2 times 10 plus 5y is equal to 30. This is going to give me 20 plus 5y is equal to 30. Subtract 20 from both sides. 5y is equal to 10. Y has to be 2. All right. So now I've got some ordered pairs. -10, 10, -5, 8, 0, 6, 5, 4, 10, and 2. So I'm going to go ahead on this piece of paper right here. And go ahead and graph it. Let's make a graph here. Six, 7, 8. 10, 10. All right. So from here, my first point is -10, +10. So I did 10 hashes for each side here. So we know that that's going to be right here. -10, 10. Then we have -5, 8. -1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. All right, so we got that right there. Next we have 0, 6. 6. Then we have 5, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. It's obviously easier with graph paper. You don't have to do all those little lines there. Try to make sure you're doing it right. This is 10, 2. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay. All right, so that's my blue line right there. Very wavy. That should be straight with a straight edge. And you'll have graph paper on your homework to deal with that, so not a big deal. All right. So now what I want to do is look at my other equation. Whoops. Look at my other equation. X minus 5y is equal to -45. All right, so how do we do this one? Well, this one I'm going to use the color green. So I'm going to put aside my graph for now. And so we're going to have, I'm just going to rewrite it so I can move this paper. Okay. X minus 5y is equal to -45. Okay. And looks like this is going to be multiples of 5 as well. I think that's our easiest bet. So let's go ahead and do that. XY. We can graph it after we figure all that out. So let's do -10, -5, 0, 5, and 10. All right, so the first thing we're going to do is plug in -10. So -10 minus 5y is equal to -45. Well, one of the cool things here is since everything is negative, I can essentially multiply both sides by -1, because I can multiply both sides of any equation by anything I want. And it makes everything positive. So if I distribute in this negative, gives me a +10 plus 5y is equal to -45 times -1, +45. All right, I'll subtract 10 from both sides, and I get 5y is equal to 35. Divide both sides by 5, y ends up being 7. All right, that's the first one. All right, let's do the second one, which is -5. -5 minus 5y is equal to -45. Now I can go ahead and multiply everything by -1, make all this positive, but let me go ahead and work it out without doing that. Just try to show some diversity in terms of how you can do this. So I'm just going to add 5 to both sides. That leaves me with -5y. And if I add 5 to -45, that leaves me with -40. Then if I divide both sides by -5, y is going to be positive. Well, let me think about this. It has to be negative, so y has to be 8. Yeah, y has to be 8. Because -5 times +8 is -40. All right, then I'll plug in 0. So this will be 0 minus 5y is equal to -40y. So that's just -5y equal to -45. And that's going to have to be a +9. 9 times 5 is 45. So -5 times 9 is -45. Then we have +5. So 5 minus 5y equal to negative 45. Subtract 5 from both sides. Left with negative 5y is equal to negative 50. Divide both sides by negative 5. Y ends up being positive 10. 10 times negative 5 is negative 50. That gives me a positive 10 there. Then if I put in a positive 10 for x, that's 10 minus 5 times y is equal to negative 45. Subtract 10 from both sides. I have negative 5y equal to negative 55. Divide both sides by negative 5, and y equals positive 11. All right, so let's go ahead and graph this one on the graph paper. It's going to be here. So we've got, all right, so the first one is negative 10, 7. Let's go negative 10, positive 7, 1, 2, 3, 4, 5, 6, 7. So that's right there. Negative 5, 8. So negative 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Up, we just found where they crossed. It's going to be that negative 5, 8. 0, 9. Right there. And we only really need a couple of points to draw a line. I'm doing several. You don't have to do this many. I'm doing it just because I don't have graph paper. And it helps me just kind of create something relatively accurate. So next is 5, 10. 1, 2, 3, 4, 5. Here's my 10. There, and then finally 10, which will be above this, 11. There we go. So we have kind of a, there, with our crossover being right there at negative 5, positive 8. So that is the answer to the system of equations. It is x is equal to negative 5, y is equal to 8, or the point negative 5 comma 8. That's graphically, we can show that right there. All right, so a couple of examples there on how to solve system of equations by graphing.